All right, so if the compound propositions P and Q have identical truth tables, then P logically implies Q and Q logically implies P, so it can go both directions. In this case, we say that P and Q are logically equivalent, so they're the same both directions. And logical equivalence is if the compound proposition P and Q have identical truth tables, we say that P and Q are logically equivalent, so we can now write instead of with the arrows, now we can write P, then three lines, then Q. And we say that I'm going to call it, that's called logical equivalence. So some logical equivalents that we have here are not P is logically equivalent to P, and P or Q is logically equivalent to Q or P, P and Q, and then Q and P. If P, then Q, and then not P or Q, not P or Q, and then not P and not Q, and then not P and Q, and then not P or not Q, and then if P then Q, and not Q then not P. Now these two, no, excuse me, these two, P, 5 and 6, these are called De Morgan's laws. So sometimes we have special cases and we name them after certain people, and these two are named after De Morgan. Okay. So what we want to do now is we want to show the following, that not P and Q, not P and Q is logically equivalent to not P or not Q. Okay, so let's go through this and write it out. So we'll have a P, we'll have our Q, we'll have our not P, we'll have our not Q, and then we'll have a P and Q, and then we'll have a not P and Q, and then on this side we'll have a not P or not Q. So what we're going to hopefully find out is these last two columns, this one and this one, these two here, are going to be identical. Okay. So we start off true, true, false, false, true, false, true, false. Not P. False, false, true, true, false, true, false, true. Now P and Q. All right, so that's going to be what? True, and then it's going to be false, false, false. So we just have the one. Now, not of this. Well, that's going to be false, true, true, true. Okay. Now, not P or not Q. So these two ors. All right. So that's going to be false. That'll be true, true, true. So it's going to be false, true, true, true. Now, notice those are identical. And so therefore, we can really say that we have that logically equivalent because those two are exactly the same. So we can go this way or we can go this way on our arrows. So what we could say is we could say Q, then P or P, then Q, but instead we're going to switch it to P, Q. So because it can go this way and this way, since they're exactly the same, we go straight to that and say they're logically equivalent. All right, let's stop there and we'll come back for one more.